At first glance, the Triangulum Galaxy appears to be a simple, elegant spiral, a textbook example of galactic symmetry. Two sweeping arms curl gracefully from its center, adorned with star clusters, nebulae, and young blue suns. But look closer, and the simplicity begins to unravel. Recent high-resolution observations have revealed something unexpected. Triangulum's spiral arms aren't perfectly uniform. Instead, they twist, branch, and ripple with surprising complexity. In several regions, spur-like structures branch off from the main arms, forming twisted lanes of gas and stars that defy the traditional models of spiral formation. Some spiral arms even appear to split and reconnect, like strands of a living organism reacting to forces we can't fully see. These features aren't random. They may be caused by local gravitational instabilities, where massive star-forming regions tug on the galaxy's fabric, or by shock waves traveling through the galactic disk. Think of the galaxy not as a rigid pinwheel, but as a dynamic, breathing structure, constantly reshaping itself in response to internal and external forces. Understanding how spiral arms evolve isn't just an academic exercise. It's a window into the very physics of galactic life. The patterns in a galaxy's arms tell a story of gas flows, star birth, gravitational waves, and even ancient collisions. In the case of Triangulum, scientists believe these spur structures could represent temporary formations, the result of massive molecular clouds pushing their way through the disk and triggering waves of star formation. In some cases, these spurs become hotbeds of stellar birth. When gas is compressed along the edges of a spiral arm or spur, gravity takes over, pulling atoms together until stars ignite. That's why so many of Triangulum's young, luminous stars cluster in these complex regions. But the deeper mystery lies not in the arms, but at the center, in the galactic core. Here, the spiral symmetry gives way to chaos. The very heart of the Triangulum Galaxy is a region of extraordinary density. Stars are packed more tightly than anywhere else in the galaxy. The rules of motion change. The orbits of stars become unpredictable, warped by the intense gravitational pull of massive objects, possibly even a central black hole. Unlike the Milky Way, which harbors a confirmed supermassive black hole at its core, Triangulum remains an open question. Some studies suggest the core is too diffuse to host a massive black hole. Others point to faint X-ray emissions and velocity anomalies as signs of a hidden monster lurking in the shadows. If Triangulum does harbor a central black hole, it would reshape our understanding of how galaxies like it form and evolve. Perhaps it is still growing. Perhaps it's smaller than expected. Or perhaps something else entirely is driving the dynamics of its core. One thing is certain: the galactic center holds clues to the galaxy's past. It may contain stars that formed during the very first wave of starburst activity. It may also hold remnants of smaller galaxies consumed in past mergers, their cores buried deep within the spiral's heart. And just like the spiral arms, this region is not static. It pulsates with motion. Stars orbiting in elliptical loops, clouds of gas colliding and spinning inward, bursts of radiation flickering like cosmic heartbeats. Triangulum's spiral design is not just beautiful, it is a record of cosmic evolution. Each arm, each spur, each ripple in the galactic disk is the result of billions of years of gravitational tension and release. And the lessons we learn from it ripple outward too. By understanding how arms form in Triangulum, we gain insights into more distant galaxies, those billions of light-years away whose faint spirals we can barely resolve. Galactic spirals are not decorative. They are maps of momentum, blueprints of birth, and records of the gravitational symphony that shapes the universe. So as we continue to observe and simulate galaxies like Triangulum, we are not merely admiring their form. We are decoding their function. discovering how a spiral becomes a cradle for stars, a mirror of dark matter, and a fingerprint of time. And at the center of it all, hidden beneath the swirling arms and luminous clouds, lies a secret that may change everything we know about galaxies, waiting as always in the dark.